Okay, 1.1, quarter 3, we're learning about logarithms. So we have all these properties. There's actually 3 of them where we can combine logs and expand logs. So the product property is similar to multiplication, and that's expanding logs. It's called product because it's multiplication. So when you're adding 2 logs, you actually multiply them with 1 log. So down here's a chart. Our law of exponents is we add the bases. And remember, exponents and logs go together. So when we're multiplying 2 numbers within a log, we can actually separate them with multiplication. So here's our example. If I have log base 6, I can actually multiply 12 times 2, and now it's 1 log, 1 logarithm. So I would have log base 6 of 24. That's actually another way to write this. So when we solve, we use these properties. Okay, also when we have division, we're subtracting. So let's see. Look how I subtract my exponents when I divide. It's the same things with a logarithm. So this is just the regular standard. But if I have 12 divided by 5, I can split this into 2 logarithms. So log base b of 12 minus log base b of 5. So now it's expanded. It's 2 logarithms instead of 1. And our last one is the power property. So if I have m times n, I can actually move the exponent in front of the log. We're taking the log and we're multiplying it by the power. One of the most useful properties, for sure. We use this one a lot when we solve. So log base 3 of 27, I'm going to rewrite 27 as 3 to the 3rd power. And then it's log base 3. So what happens is I can take this exponent in front of the log and multiply it. So I have 3 times log base 3 of 3, and if you remember from last quarter, that equals 1. So the answer to this would actually just be 3 using our power property. There's one more property you need to remember. I have m over n. So I have some number to the power of a fraction. We can rewrite this. This is called rational exponent form. And in, I think, one of your questions, you're going to have to know how to convert to radical form. So you take the denominator of the fraction becomes what we call the index of the radical. The base stays the same. And then m is a power on the numerator. So that's going to come up in a later question. I go over it in that question as well. But just remember to be familiar with that. Those are our log properties.